Welcome back to my channel Bal Vigyan Bharti, and this is your mentor Avilash Sarkar. Today we will take up a new subject on mathematics, that is trigonometric ratio. Till now we have talked about physics subjects, that is vector and this property. As I said that we will come back to the mathematics subject, then after I will rotationally I will move into physics subjects again. But as of now I have taken a very serious subject, that is vector. So the people might have be very much troubled by understanding that vector concepts is very typical subjects to understand, but it is all that at the same time is very interesting too. But now to ease that moment, ease that you can say the understanding, we have bring some new subject that is respectively very easy. So that is the trigonometric ratio. So we'll start this chapter with the understanding of the trigonometric ratio, its definition, and then after we'll establish the concept. So trigonometric ratio is the ratio where the sides of a right angle triangle are specifically related. Okay. So this case will consider it on a right angle triangle. You know what is right angle triangle? Where any triangle whose one angle is 90 degree, this is called right angle triangle, and this angle will be the maximum angle of that triangle. Other two will be the acute angle, that means these are less than the 90 degree. So specifically if I name it ABC, so that the highest side is called hypotenuse. If I consider any acute angle, that means B, the adjacent side is called base, let's say B, and the opposite side is called the vertical or perpendicular. So C for a right angle, it is hypotenuse, B is called the base or adjacent, and A is called the perpendicular or the opposite side. Okay, so these are the nomenclature or the associate terms. So here I am considering acute angle B, but if I take acute angle A, the respective base will be this perpendicular, so that will reverse. Now we talk about the ratios. The ratios are related such that if I take any angle of B, for angle B, if I take, so the ratios are named. First let me introduce the name. Sine, we abbreviate as sine. Cosecant, we call it cos, abbreviated form. Tangent, we call tan, GENT, tangent. Then their reciprocal, that is sine reciprocal, will be cosecant, that we called cosec. The cosine reciprocal is secant, we called it sec, and the tan reciprocal is cotangent, or we call it cot. So these are the things: sine reciprocal this, cos reciprocal this, tan reciprocal. So these are the ratios. Now I will talk about one by one. Okay, if I talk about sine of any angle, I considering sine of B, if I consider, So in that case it will be the vertical side by the hypotenuse. If I talk about cos B, it will be the base upon hypotenuse. If I talk about tan, then it will be vertical about the base. So now reverse of that will be cosec will be C by A, sec will be reverse of cos, it will be C by B, and the cot it will be B by A. So these are the basic relations of that. Now we'll correlate these relations according to the coordinate system. So the trigonometric ratios versus coordinate. So if I want to put it in relations, so we know our coordinate system in 2D system, in 2D plane you can say, in 2D plane the coordinate systems are made up by two mutually perpendicular lines. So those lines are of x and y, and the respectively the intersection points is called the origin. The right hand side of the origin of the x-axis is called positive x, left hand side is called negative x. The top of the origin as y is called positive y, and the below the origin is called negative y. This is the basic orientation of a coordinate system. Now we are considering a line which are being rotated with a vertex on the circular path. So if I consider, so in that case when the path will form a circular, so these are the radius whose tip is on the circle. So now I am considering two cross lines which are drawn in such a way that they will make theta angle to the respective x-axis. So that means if it is in first coordinate, so I introduce this is first, this is called second coordinate, this is called third coordinate, this is called fourth coordinate, this is coordinate, and this first coordinate lies between 0 to 90 degree, second is called 90 to 180 degree. So that means degree means this positive x initial is it's 0 degree. When it is started rotating, it will create up to 90 degree, then 90 when crossing this is, it is reaching, after 90 it is reaching to second coordinate, after crossing 180 it is moving into third, and that there when it is crossing 270 it is to fourth coordinate. So these are the orientation of that. So now the third is between 180 to 270, and that of this is 270 to 360. So these are the separation of angles. Now if I draw this cross lines such a way that every time they will make theta degree with the respective sides, and this time I will join these lines, so every time this will make a 90 degree. This is right angle triangle. So now we will consider the case of first coordinate, the ratios. If I take sine of theta, this will give how much? Now this I am taking coordinate x and y, so respective coordinate here it will be minus x and y, because theta is making, so this vertical will be same and respective x will be same. In that coordinate will change here as minus x minus y, and this coordinate will be minus x minus. So because theta is same, so respective x and y will be same, so accordingly x and y will change due to the coordinate, as because we know this side anything x is negative, so this every time x is negative, if I go up then y will be positive, if I go down that y will be negative. So this way the coordinate system is like that. So if I now calculate the sine of theta, so sine is nothing but vertical by hypotenuse. I am taking it, radius is r, so this is x, sorry, sine is y by x. Cos of theta, if I consider, this is x by r, and considering tan theta, it is equal to y by x. So now you can see the every ratio in this first coordinate are positive because x and y both are positive. So we can take write it a, that means all are positive. So as because this direct ratios are same, the reverse of that obviously to be positive. So I am not writing that. I am concentrating on the first three ratios. Now moving to the second coordinate. Okay. So now if I calculate sine of theta here, that is equal to how much? Sine of theta will be this y by r, sorry, I made a mistake, this will be r. So y by r, cos of theta will be how much? Minus x by r, and tan of theta is equal to minus y by minus x, that means minus x by r ultimately, because that sign of x will be a common there in between. So minus, so you can see only sign here it is positive, other are negative. So the reciprocal also be negative. So all sign whatever I am writing here, that will be positive in that coordinate. So all will be positive here, sign will be positive here. Now want to bring one more relation, or you can say correlation, or you can say the relation between the two coordinates, the ratios of with respect to the second coordinate. Now this angle I am taken as theta because this is value wise it is same, but ultimately I have to calculate I have to consider the angle in a positive direction, because the orientation of angle measurement is anti-clockwise, always anti-clockwise. Okay, and that has to be positive. Whatever angle I am measuring with respect to the positive x, taking as a 0, that anti-clockwise whatever with the angle, it will be considered as a positive. So I cannot take the angle negative. So ultimately if theta have to be representing this position of the arm, so actual angle will be something. If I go 180, then I deduct theta, because theta magnitude is theta. So this will be 180 minus theta. I can reach here the exact angle for this. So I can write here, it is the actual angle will be 180 minus theta. So that will be for everything. So sine of actual angle is 180 minus theta. That will give you the same ratio, because this will depend on the angle of this to calculate the ratio, but actually the measurement will be 180 minus theta. So this will give you the same ratio, sine is equal to y by r. Okay, this is second coordinate. So similarly this will give you the cos, exact angle will be 180 minus theta, so that is equal to minus x by r, and tan of 180 minus theta will give you minus y by x. Now if I consider these ratios, because ultimately the value wise these values and here y by here has to be same, because y value is same, r are same. So only thing is that wherever there is a change due to the sign, that will reflect. So if I want to correlate, sine 180 minus theta is y by r, here is sine theta. So I can conclude sine of 180 minus theta is equal to sine theta. So this is a one corollary for the equation. And the same, if I consider cos 180 minus theta is equal to minus x by r. So the cos of 180 minus theta which is minus x by r, minus x by r is equal to cos theta. So that I can write is equal to minus of cos theta, and tan of 180 minus theta, that also I can write is minus tan theta. So from here I am to bring one standard. It is that sine of 2 into 90 minus theta is equal to sine of theta. So that means wherever that even number is multiplying with 90, minus some angle will give you the same sign. Okay, only thing is that I have to correlate the thing. Sine 2 into 90 means any even multiplied to the 90 will keep the ratio as same, but whether it is positive or negative, that depends on the coordinate. So for first two coordinates, here it is positive, here also sign is positive. Now if I see cos of 2 into 90 minus theta, so as because this is minus cos theta, I can write for 2 into 90 cos will be cos, okay, cos theta. As because here cos is negative, so this will give you a negative sign. So for any even multiplication of 90, the ratios will be same. You can follow it for tan minus theta is equal to 2 into 90 means tan will be 10, straightforward, because this is even multiple of 90, but as because this is the second coordinate, it will be negative. Okay, so these are the three corollary where sine of 180 minus theta is equal to sine theta, cos of 180 minus theta is equal to minus cos theta, and tan of 180 minus theta is equal to tan theta. So up to this for today. In the next I will continue for the third and fourth coordinate. Okay, this will be interesting because I will establish few more corollary for other system too, because when it is crossing 180, what would be the relation among the first coordinate ratios and the third coordinate ratios, that can be established. So that will give you a general assumptions or understanding wherever any multiple of that angle, how will you treat the ratio. Okay, so thank you for now. This will take few more weeks to understand the ratios, because thereafter we will solve few more standard relations between the ratios where the angles being multiplied several times. So there I will establish some standard relations among them. So thank you for now. Good night.